Derivative of y with respect to x by implicit differentiation. I just want to give you a chance to work through this example, apply what we did yesterday.
All right, let's get it.
So work through it. We'll see what we come up with. I'll, in a minute here, be walking around. I can answer questions, check what you have. Remember, other derivative rules apply. You might need chain rule. You might need product rule. You might need quotient rule. Whatever you need, they still apply.
What did you just do?
What's up, man?
It smells toxic.
I didn't do nothing.
You.
I went to that.
No, you didn't. Yep. Okay, good. Magical power.
Yeah, we're out.
Oh.
Oh, do you drive? Do you have your license or?
Do you mind? Yeah.
No.
You hot, bro? Yeah. You didn't even do push-ups, though. You didn't do push-ups? Well, is it? Oh my God.
Look at that.
Oh no. I have to distribute it in.
Shoot.
Like that time you had that.
Okay, so it's half.
Oh, with respect to why?
How would you differentiate 1 plus x squared?
Okay. Here we go.
You good, young blood?
Well, would that be 2y times y prime?
Oh, geez, that's screwed up. No, that might be correct.
Probably not.
Yeah.
I would write it as that. This is just generating. Oh. This is just showing
I don't even know how to do it. I think I did this wrong.
I only have one for the derivatives.
Yeah, exactly. Now we get y prime by x.
Oh,
Yeah.
Yeah, what's it look like? Nope. That's wrong.
You got it right?
Hold on, young boy. Hold on.
Only two.
No, I got it. This is
Need your help.
Wait, what the heck?
I'm gonna show one thing and then come back because I haven't finished the whole thing yet. I will get to that. Okay, I'm just going to, this isn't the final answer, but for you just to check, and I know some of you might be stuck on what comes after this, but what I have here, actually we could discuss this together and then I could have you do it. So what I have in this line, this is just taking the derivative of both sides. So this is not the final answer. So this side here would be a chain rule. So here's the derivative of the outside, leaving the inside the same. The derivative of the inside is a product rule, which I showed over here, and that's this here, the derivative of the inside. The right side is also a product rule. I showed that up here, and this is what I have. So then if this is where you are stuck, I'm still going to be walking around, but if this is where you are stuck is, okay, now where do I go from here? You have to solve for dy dx, or y prime if you wrote it as y prime. And to do that, on the left side, you have to distribute this quantity to these two inside of that parentheses. So this whole thing gets distributed to these so that you have a clear term with dy dx. Okay, now when you do that, you cannot change anything in this parentheses because it's to the -1/2 power. So it's really just multiplying the 1/2 by everything else that's there. So for example, when I distribute it here, I'm going to have the 1/2 and 2 cancel. So I would just have x squared y dy dx times the quantity 1 plus x squared y squared to the -1/2. So it's going to look messy. And then to the next term, again, the 1/2 and the 2 would cancel, but you'd have xy squared to the quantity 1 plus x squared y squared to the -1/2. Oops, I don't need that there. Equals, I didn't change the right side. So that might have answered some of the questions you have. From here, solve for dy dx. Yes, or you can write it as y prime, if you'd rather write y prime. So I don't know, those of you that had to hand up, did that answer your question?
Bruh. Run.
I never get paid.
No, she's not.
Just think, guys, I don't do that.
Hey, wear glasses. Huh? Wear glasses. You finish this in like 2 seconds. What? If you wear your glasses, then you know what else to do.
It's huge.
Yeah, it is.
Oh, the thick humans.
Oh,
The struggle bus. What? What's for you? Zero shifts on Thursday.
Want to go get it back up?
Oh, that's a good one.
That's not very encouraging.
Well, one definitely not. The only I would take it if it was. I was thinking. Good enough, right? I would take it. It's 6 hours. I think we need to move the hour. Yeah, it really messes up.
I have no control over that.
I can't keep thinking.
And we can't take like any college classes because it's right in the middle of the afternoon.
I don't make the schedule.
I know, I
Can we
made the
change it?
schedule.
When do you have practice?
I made the schedule.
7th hour.
Throw your blame on me. I'll take it.
Time to riot.
Can we have this first maybe like third.
That's my.
And it can't be, no, it can't be before lunch.
Yeah, it can't be right after lunch because your boys get tired. I got it.
That is honestly
Just get rid of it. How about this? We just don't have that. We all get paid. Advisory.
Right.
Perfect. Night school.
Yeah.
Really?
All right, here, double check. See if you have.
What retardation?
Oops.
Oh, don't show.
Whoa!
Well, don't look. It's up there. Don't look if you don't want to see it again.
You can look at that for a minute too.
I did.
Oh, your boy got it. You didn't even finish it, bro.
I don't know how.
Bro, sure. You subtract this quantity to get it to this side. You subtract this quantity to get it to this side. Factor out dy dx, and then you subtract what's left.
Oh,
Or divide what's left. Sorry.
Frick. That does make sense.
Yeah, it does. That's simple.
I swear, you're saying right?
Well, you do that stuff. You do that stuff.
Yeah, actually, you do this all the time. Oh, that's what I X squared should
Oh, yeah.
be. My confidence is gone.
Yeah, it's x squared y.
Oh, yes!
What? 2y?
Guys, I'm gonna start ready to freeze.
Bang! It's gone. It just vanished.
Yeah, at the bottom should be x squared y in front. I dropped my x squared.
Oh, hey.
It's frozen. It's frozen, bro.
Oh, that makes sense. Oh, definitely going.
Alright, what do you? That's what you write about. Bro, I'm digging college stuff.
Hey, we are wearing capris one day, alright?
Sure, maybe in the spring.
Yeah, we'll wear them in the spring.
I'll cut them off, bro.
Why are they so ridiculously short?
Because I pulled them up. And they're stretchy, so they stick.
So you're looking at
We got the American Eagle.
Hey, bud. Go in there.
Fantastic.
Your glasses. Why don't you wear those all the time? Because your IQ goes like this. It's all about perception. When people perceive you a higher IQ, you then have a higher IQ.
Yeah.
Because you think you have a higher IQ. Out of what? See?
Oh.
I condone that.
I've got my high race. I'm going to take a stroke from one range. Go off on what This is like, she would like use it starts here.
Yeah.
It's the hairiest one I've ever seen. No, look at my
This goalie's like on fire. Nothing can stop him.
That was right. No, that was right.
No, it's still good though.
Hey, get out of here.
What was that? I got this.
No, do not tell her.
Really?
Yeah, it's like a emergency code number. I'm serious, yeah. It is.
That's stupid.
Well, no, that one is the universal emergency phone number before.
This is like a conference.
It's not.
It's not. No.
Oh, I need to other side of the state. I know 4 hours.
Hey, Chang, you working on it? What the heck?
All right. Now realize, if you hadn't looked at the practice from last night, this with the product rule within the chain rule, within the implicit differentiation, it's complicated.
Let's just leave out his answer. dy dx. That's complicated.
Just writing that out.
Yeah. Yeah,
No.
that's our explanation for how we got it.
That wouldn't be the appropriate justification. It's complicated. But it is. But make sure that you are asking questions if you have them. We're going to move ahead. The next part of this, derivatives of inverse trig functions, we only focus on inverse sine and inverse tangent. So those are the 2 rules you need to know for inverse functions. Do you need to know how to use implicit differentiation to get the derivative? No, I'm showing you where the rule comes from based on implicit differentiation, so it's kind of like the proof for it. You just need to know what the derivatives are. So I have up here for inverse sine, so remember this is arc sine, but this means, since it's the inverse function, that for sine of x, the x and y are now switched, so it would represent sine of y equals x. That is what inverse sine means. And then y for the inverse, y is between negative pi halves and pi halves. So that is the range of inverse sine. So we are going to differentiate sine of y equals x implicitly with respect to x. You can see why the rule is what it is. That would be explicitly, but that would just be the rule. I'm trying to show you where it comes from. So I am going to differentiate both sides with respect to x. And then for sine of y, what would that derivative be with respect to x? Yeah, so cosine of y times dy dx, or times y prime, equals, and then the derivative of x is 1. Connor, did you get that written down?
Yeah.
So I can move it up. Okay. All right. So then from here, we're trying to find the derivative. So we can solve for dy dx, divide each side by cosine of y. So dy dx equals 1 divided by cosine of y. Now, because we're really trying to find the derivative rule for inverse sine of x, we want this derivative to be in terms of x and not in terms of y. And we can get it in terms of x. And this is kind of where the proof part comes in, using trig identities. So I know by trig identity that cosine squared of y plus sine squared of y equals 1. And how I'm going to use this, I have a cosine of y in the denominator, so I'm going to solve this for cosine of y. So I can subtract sine squared of y. Oops. So cosine squared of y equals 1 minus sine squared y. And then take the square root. Now, because y is between negative and positive pi halves, that is where cosine of y would be positive. So we're going to use the positive square root, since technically when you take a square root, you have a positive and a negative. So it's only the positive square root because of the restrictions on y. And then from here, so I don't want to replace cosine of y with this because it's still in terms of y. But if we go back up to our function, sine of y is x. So sine squared of y is x squared. So I can say cosine of y is the square root of 1 minus x squared. That I can then substitute in. So dy dx, the derivative of inverse sine, is 1 over the square root of 1 minus x squared. This, yes. That is the final derivative, yes. So I did include on the back of this, because we're going to go through the same type of proof with inverse tangent, that is just a derivative rule. The derivative of inverse sine of x is 1 over the square root of 1 minus x squared. Okay, honestly, when I learned derivatives, I just made flashcards. It's memorizing. The derivatives of trig functions, the derivative of inverse trig. We'll be getting into derivatives of logarithms, derivatives of exponential functions, all of those rules. It's memorizing what they are. There is a derivative of inverse cosine. It's just not one that you're expected to have memorized. I don't know. It's not on the AP test. Okay. We are going to, like I said, go through a similar proof for inverse tangent. Inverse tangent, you can see what the derivative is. It's 1 over 1 plus x squared. I'm going to show you where that comes from by implicit differentiation. So if we had y equals inverse tangent, this means tangent of y is equal to x. So if we go through that same process, take the derivative with respect to x of both sides. What is the derivative of tangent of y? So derivative of tangent is secant squared of y times dy dx equals the derivative of x is 1. Again, solve for dy dx. And that'll be 1 divided by secant squared of y. And then from here, going off of that trig identity of cosine squared plus sine squared equals 1, when you divide everything by cosine squared, you get this trig identity, secant squared, I'm going to be using y, equals 1 plus tangent squared of y. So that trig identity comes from the one we just used before. And why this is helpful, so I have a secant squared of y. I don't want to replace it with 1 plus tangent squared of y because then I'm still in terms of y. However, tangent of y is x, so tangent squared of y is x squared. And that I can substitute in to get that the derivative with respect to x is 1 over 1 plus x squared. Okay, so ultimately, again, I'm just showing you where they come from, but you need to know for inverse trig, only inverse sine and inverse tangent. Between the two, inverse tangent comes up more often. And when we get into integrals, inverse tangent is used even more. So, yes, those two you need to know. Okay, so then I just included a couple of examples that include inverse trig functions in them. So if you had to differentiate y equals 1 over inverse sine of x. Any idea where you would start? Plug what in? It will be chain rule, but why? Yes, this is not, by the way, this is not implicit differentiation. How do you know if it's implicit or not? If it's y equals something with x, you don't need the implicit differentiation. Okay, so implicit differentiation was used to find these rules. Both of these examples, 5 and 6, these are just find the derivative. So you're using these rules, but implicit differentiation you don't need. I can rewrite this as sine inverse of x to the negative first power if I were to bring it out of the denominator. If you don't bring it out of the denominator, you have a quotient, and you would need the quotient rule. So you can't just take 1 over the derivative of sine inverse. You would need quotient rule if you left it. This is not the inverse, though. This is the reciprocal, if it's to the negative first power there. So this negative 1 means the inverse of sine. This negative 1 means the reciprocal of it. So chain rule, so y prime, derivative of the outside would be something to the negative first power. So negative 1 times inverse sine of x to the negative second. And then you have to multiply that by the derivative of inverse sine. And that is the 1 over the square root of 1 minus x squared. Okay, so if you left that, that is the derivative. If you left that, that is the derivative. If you didn't want to leave that as your answer, yeah, AP test would rewrite it. You could write it so it's negative. This means inverse sine squared would be on the bottom. So it'd be 1 over inverse sine of x squared times the square root of 1 minus x squared. So you could write it that way, or it would probably be written that way in a multiple choice question. Either the end of today or for sure tomorrow. I want you to, well actually no, we're going to go through 6 together, so I want to make sure that you understand this one part.
Stop penetrating my folder.
Y equals x times arctangent of the square root of x. So arctangent is inverse tangent. If you like the inverse tangent notation better, you could rewrite it. But knowing that that is inverse tangent, what is needed here to find this derivative? You need the product rule, and you'll need the chain rule because you have the square root of x inside of the inverse tangent function. So if I let the first function be x, the second be arctangent of the square root of x, derivative of x is 1. So now derivative of arctangent of the square root of x. So it's the derivative of the outside leaving the inside the same. So the inside is left as the square root of x. The derivative of the outside is this rule here. So where you see this x, that will be the square root of x because you have to leave the inside or the input the same. So the derivative of the outside would be 1 over 1 plus the square root of x squared, which is just x, but I want you to see where the just x is coming from. And then you multiply that by the derivative of the inside. So the square root of x is x to the 1/2. Derivative is 1/2 x to the negative 1/2. Okay, so I'm going to simplify this. It would be 1 over 2, the x to the negative 1/2 would be the square root of x in the denominator, times this quantity. So times the quantity 1 plus, and again the square root of x squared is just x. So if you wanted to write it all as one simplified fraction, this would be it. That is just the derivative of the arctangent part. And then you can apply the product rule to that. So we would have first times second prime. So I'll write that as x over 2 square root x times the quantity 1 plus x, plus second times first prime would just be arctangent of the square root of x times 1, so just arctangent square root of x. This really could be simplified further as just the square root on top, because this would be x to the first over x to the 1/2, so you could just write the square root of x and then not have the square root of x in the bottom. Yes, Danica. Yes. Yes. I know